In this next lab, I'm going to introduce for you the Pendulum Lab, okay? And same website, copy paste the link or just go straight to the website, simulations, right? fat.colorado.edu. I'll choose physics because that's what we're doing. And check all the boxes except for the motion. And automatically it gives me the HTML5, that's what I want. And I want the Pendulum Lab. Let's see where it is. That's the Pendulum Lab. So click on it and click on it again. It should open on the browser. And we will go to the lab. Double click. That's it. That's the Pendulum Lab. So the Pendulum Lab asks you to do a few things. You will first hang different masses. You will choose the length of the pendulum to be 1 meter, and then you will hang half a kilogram, 1 kilogram, 1.5, and then you will see what the simulation is. Okay, what the simulation is. And then I ask you to calculate it using equation 1. Here's equation 1. It says the period is 2 pi the square root of L over G. So it does not depend on the mass. So the mass should not affect the period. And that's what you will see here. So for instance, here it is. In this case, the mass is, let's choose the length to be 1 meter. And then the mass is, I think, I ask you to do 0.5, 1 kilogram. And so let's do the 0.5 kilogram, so 0.5. I ask you to tilt it by about 10 degrees. So we tilt this by 10 degrees to, let's say, the right here. And then you will let go. Let me get the period timer. So here's the period timer. So I will just click on it at any time and it will just calculate for me the period, which is the time it takes to do one cycle. So it says 2.0099. So I noticed they're using G as 9.81. So when you plug G in the lab, make sure you also use 9.81 because that's what they're using. So 2.0099. And so that's the period. And then you will plug it into the formula here, use 2 pi. So 2 pi, square root of L over G. L is 1 meter, and then 9.81, square root of 2 times 2 pi. And see if it's 2.00. Yes, it will be about the same. And then you choose 1 kilogram and 1.5 kilogram, and it will be exactly the same. So if I, let me just show you here. Let me increase it to 1.5 kilograms. And let it go, and let's calculate the period, and it's exactly the same. Okay, that's fine. So we just wanted to double check that the mass does not affect the period. And the next one is we're going to change the angle. We're going to see how the angle affects the period. So we're going to use 1 kilogram. The length of the pendulum will still be 1 meter. So we're going to make the mass be 1 kilogram, and then the length is 1 meter, and we're going to tilt it by 5 degrees, start, and let it go, and then the period is 2.0070, so 2.007, that's the period from the simulation. The period using equation 1, well, you plug in the length, the square root of L over G, and then times 2 pi. So this here, because it doesn't depend on the angle, notice this equation here doesn't account for the angle. It assumes the angle is small enough that it doesn't depend on it. So there is no angle. So as long as L is fixed and G is still 9.8, it will give you the same number. So the numbers on this equation here will all be the same. Okay. Then I ask you to use equation 2. Equation 2 does not assume that the angle is small, and equation 3 does not assume that the angle is small either. Notice the angle is 5 degrees, which is 0.087. Change it to radians, that's what I get. And here's equation 2. Here's equation 2. It says you do 2 pi square root of L over G, that's the same, times parentheses this whole thing, 1 plus a quarter sine squared of this theta m. Theta maximum is the maximum angle I started with. So if I start with an angle of 5 degrees, I'll plug in the 5 degrees here. But make sure you're in radians because Excel does not understand degrees. It understands radians. And then 9 over 64 sine to the 4th of this. And then this 25 over 256 sine to the sixth. That's equation 2. And then equation 3 is this. It says 1, and then the angle here is also in radians. So theta squared is theta in radians. So it is in radians, and you plug it here, and you get, I put these first two numbers here. Don't do it by calculator. Do it using Excel. Because if you do it using your calculator, you're very likely to make a mistake, and you will spend forever completing the table. So you want to do it by using Excel. Okay, you want to do this using Excel or Google Sheets. So you will start increasing the angle. So let me show you how you increase the angle. Let me pause first. You put it at 10 degrees, let go. It will give you a certain period. And you will notice that the period will increase as you increase the angle. So here is at 90 degrees, for example. Let go. And then let's see what the period, it's 2 something. It's more than the 2 point. And then I ask you to do 179. How do I do 178? So keep spinning it until it goes off screen. Right? That's the maximum. Let's see where it is. 179, 177, 179, right there. Let go. And let's start counting the period. It will be a larger period. So the period is 7.82 seconds. Okay? So in here at 179, so the period from the simulation is 7 something seconds. Now these formulas, how do I enter them into Excel? Let me show you how you do that. Where is Excel at? Excel. Okay. So this is the angle in degrees. And then let me make this larger. And then the angle in radians. Okay. So let's say the angle here is 5, 10, 15. How does it go? Yeah, 15, 20, 25, 30, 35, 40. Yeah. So it just follows that order. 5, 10. And let's see here if Excel can pick the pace here. Yeah, it will increase by this. Let's keep going all the way to 180. Actually, I'm not sure if it keeps increasing by 5 or not. At some point, it will increase by 10. That's fine. You can always change that or delete some of the numbers. So 175. Let me do here 179, 79. Okay. How do I change from degrees to radians? I did it on the Word file, but I put this equals. So you multiply by pi and divide by 180. So equals to, this column here is A4 times pi over 180. So pi and then close parentheses. Now Excel understands it's pi. So put that, and that gives you this. And then click on this cell, go to the right, drag it all the way to 179. That's your angle. So at 180, it should be almost pi, 3.14. So this is 179, 3.12. Fine. Now, formula 1, equation 1 or 2, I forgot. This one is equation 2, and this one is equation 3. So equation 2 and equation 3. Let's go equation 2. So what does equation 2 say? It says I have equals, let's see, 2 pi, the square root of L over G, and then times that whole thing. So equals 2 times pi, close parentheses, times, I put close parentheses here, and then let's see, L over G, L is, so L is 1 meter over G, which is 9.81. and it's the square root, so to the 0.5. So I'm done with that part. And then it says times the stuff here. What's the stuff here? 1 plus 1/4 sine squared theta maximum over 2 plus other stuff. So 1 plus, I put 1 over 4. Use parentheses so the order of operation doesn't get confused, times, and then the sine squared. So sine squared I put to the power 2. Sine of what? Sine of theta maximum over 2. Theta maximum is in this column here. In radians, it's B4. So B4 over 2 squared. Okay, that's good. And then plus what? The next one is 9 over 64 sine to the 4th. So 9 over 64 times, and then sine to the 4th. I put open close parentheses to the 4th power, and sine of, well, again, it's B4, right? B4 over 2. B4 over 2, right? Because it's, theta over 2. And then finally this one. By the way, it's an infinite series, so it keeps going and going. And then the next one is 25 over 256. So open close parentheses, inside the parentheses I click here, 25 over 256, and then times sine, open close parentheses, to the 6th power, sine of B4 over 2, and this should work. I hit enter and it should work. It gave me this. Then I drag it all the way. See, if you did it with calculator, you would be doing each cell by itself. But now I did it by calculator, and that's that. I got 2.98 all the way here. Now equation 3. Let's see what equation 3 gives me. So the period from equation 3. So we put, here is equation 3. Same thing, 2 pi L over G, and then this stuff here. So we can put, so here, equals 2 times pi times to the 0.5, meaning square root, L over G. 1, L is 1, 9.81 for G. So that's that part. I'm done with that part. Times, open close parentheses, 1 plus what? Well, notice, this is equation 3. 1 plus 1/16 theta maximum to the 2nd power. So 1 over 16, close parentheses, times to the 2nd power, and it is B4, because that's where the angle is in radians, right? Yes, okay. And then plus, open close parentheses, and then something times theta to the 4th power. It's 11 over 3072. 11 over 3072. 11 over 3072 times B4 to the 4th power, and then plus something times theta to the 6th power, I think the other one, to the 6th power, and so it is B4, but what's in front of it? It's some large number. 173 over 737 to 80. 173 over 737 to 80. Okay, hopefully this works. Hit enter, you get a number. It should be very close to each other, but as the angle grows, they change also. Okay, so we get that. Okay, so as the angle grows, they get totally different numbers. Okay, and So that's that. And then there are some questions here. And then I ask you to change the length now and then find the period. So keep the mass 1 kilogram. So let's go here. Where is this one? Oh, okay. Let's just pause it. Let's just make the angle 10 degrees and we're going to change, I think you tilt it by always 10 degrees and then change the length. So you find the period when L is 0.1. Let's see. So when L is 0.1, run it, find the period, short period, and then do it again when L is 0.2, run it, find the period, and fill out the table here, and then you're asked to make a plot. Okay, and yeah, so that's that. And this brings me to the end of this one. I don't want to make it too long. We'll discuss it also in class.